Hi, today we're going to talk about section 8.3, absolute value equations and inequalities. So we're going to look at both equations and inequalities. And we're going to kind of do these just like we have done before when we go to graph them and then when we go to do interval notation. The absolute values though require a little bit of finagling before we kind of get to the graphing parts. And these are very, they're not hard, there's a lot of steps, so you might want to take some note cards and write down the steps so you don't forget all the steps. So let's look at the first one. First, let's talk about the definition. So absolute value means the distance away from zero. So there's a couple numbers that have the same distance, 5 and -5, because distance is always positive. So anything in the absolute value always comes out positive. So normally when you work equations, you do what's inside, and then whatever your answer is, both positive or negative, it always comes out positive because the distance is positive. So when we look at these equations and inequalities, we have to consider both the negative and the positive numbers that will work. So let's look at the first one. So the first step is to always isolate the absolute value. So that means you don't put anything in it, you don't solve what's in it, you don't subtract or add or divide or do anything in it, you get it all by itself. And then you split the problem into two parts. And when you split it into two parts, as long as it's an equation, you just have to change the sign of, in this case, like the 19 to a -19. We'll talk about that in just a minute. So the first thing I'm going to do, since the absolute value is all by itself, I'm going to split it into two parts. So the first part would be 2x plus 3 equals 19. And this is normally the exact same problem. Equation 2 is the exact same absolute value. We never touch what's in the absolute value, but we change the sign because we want to look at the negative side. So I'm going to subtract 3, divide by 2, and I get x equals 8. I'm going to subtract 3, divide by 2. So you can see in this equation, both -11 and 8 will satisfy the equation. And as long as you have an equal, you're going to have just two or one solution. So if you wanted to put it in that fancy set notation, which I rarely do, you would use it like that. All right, so let's look at one that's the absolute value is not alone. So again, we don't change anything in here. All we're trying to do is get that by itself. So we solve these like equations. I'm going to add 2. Then I'm left with 2 absolute value of x plus 5 equals 20. I do not distribute the 2 in there. I leave this alone until I get it all by itself. I'm going to divide the whole thing. Since this is a 2 times, I'm just going to divide it so I get this x plus 5 all by itself. Now I'm ready to split it into two equations. So the first equation, x plus 5 equals 10. It is identical to the first. The second one is x plus 5 equals -10. That's the only thing you change. You don't change any other sign. And now I'm going to solve. X equals 5. X equals -15. So the two numbers will be -15 and 5. And if you notice, your book will always put the smallest number first. Okay, let's look at something that's a little bit more complicated. So let's look at the inequalities since we've looked at equations. So when we have a greater or greater than means or, so our interval notation will include all of the solutions. The intersection will be the overlap on the graph. So in this one, when we flip it, we have to do some things to the second equation. We're going to flip the inequality sign and we're going to change the answer to the opposite sign. So let's look at an example. This absolute value is all by itself, so now we're ready to split. So the first equation is 2x minus 6 is less than 4. The second equation, we change this part. Okay? So it's still negative 2x minus 6. You can see I didn't touch any sign or do anything to stuff that was in the absolute value. Change this to a greater than or equal to, and change this to a negative 4. Now I'm ready to solve. Negative 2x is less than, I'm going to add 6, that gives me 10. I'm dividing by a negative. There's that key in inequalities. I have to flip the sign. And I'm dividing by negative 2 gives me a negative 5. Again, I'm going to add 6. Again, I'm dividing by negative, so I have to flip the sign. So x is less than or equal to negative 1. So now I'm going to graph like we did in the previous videos. I need a negative 5. I need a negative 1. So x is greater than negative 5, so bracket goes all the way to positive infinity. Less than or equal to means all the ones that are to the left. So my bracket's here, and my arrow goes all the way to negative infinity. Since we were looking at less than or equal to, we need to look at the graph that overlaps. In this case, it's here. So it's negative 5 to negative 1. We had square brackets on each side. There's our solution. So any of these numbers in between will make that equation true. So again, looking at the inequality here makes a difference how we graph, how we put in interval notation. Let's look at the next one. The absolute value is not by itself. Again, we do not touch anything in here. So I'm going to subtract 4. Again, I do not distribute the 3. I divide the whole side by 3, and I get x plus 1 is greater than or equal to 7. Now I'm ready to split it into two equations. So I've got x plus 1 is greater than equal to 7. My second equation is x plus 1 is less than or equal to negative 7. This is the one that you have to be careful with. You will forget to do it, and then forget how we changed the signs. So I'm going to solve. Let's subtract 1 from both sides. Subtract 1 from both sides. So these are the two inequalities that I'm going to graph. So I need a negative 8 and a 6. All the values are bigger than 6 or equal to 6. All the values on the number line are less than or equal to negative 8. Now my interval notation, that's the tricky part. Am I looking for overlap or all of them? I'm looking for all solutions. So it includes all of these and all of these. So I go from negative infinity, it goes to negative 8, parentheses, hard bracket, it looks just like my graph, union because I want all, hard bracket on 6, and it goes to positive infinity. So a key here is to get it down to where you can split it, and then the splitting's a little tricky on the second equation, and then the interval notation is a little tricky. So let's look at another one. So again, we're going to get the x minus 2 all by itself. So I'm going to add 3. So I get negative 4, absolute value of x minus 2 is less than 24. Again, I do not distribute that in there. So I'm going to divide both sides by negative 4. And at that moment right there, I divided by a negative. So now I have to flip the sign. So x minus 2 is greater than negative 6. Now I'm ready to split. The first one is the exact same. I just dropped the absolute value. The second equation is x minus 2. Flip it, change the sign. So x is greater than negative 4. x is less than, I'm going to add 2. These are the two things I'm going to graph. When I go to put it in interval notation, I have to look at the less than. I need the overlap of the graph. So I need a -4, an 8. All the values are bigger than -4 but do not include -4. All the values on the number line are less than 8 but do not include 8. So the point where they overlap is from -4 to 8, and I have soft brackets on either side, and that is my solution. All right, that's it. Thank you.